Hello, welcome to this lecture. Today I'm going to discuss how to conduct factor analysis in SPSS. What is factor analysis? It is a statistical methodology mainly used for data reduction and structure detection, where we examine the underlying relationships between the variables. And it's common in education, social science, and psychology. Before we run factor analysis, we need to check the assumptions of factor analysis. One assumption is sample size. The sample size has to be at least 5 to 10 times the number of variables. We need to make sure that the cases are at least 100. Other assumption is correlation matrix, where the variables should correlate reasonably. It means the correlation coefficient has to be greater than 0.3. And we need also to check the KMO and Bartlett test, where these tests show us if there is a need to run a factor analysis. The acceptable value for KMO is greater than 0.6, and for Bartlett's test, the p-value has to be less than 0.05. And the steps, first we need to open a data, and that data has to be with correlated variables and very complex. So we are going to represent the many variables which are correlated with fewer variables which are uncorrelated. And then we will run factor analysis. In running factor analysis, we need to extract and also do rotation, and then finally interpret the results. So now I'm going to show you one example using SPSS. In this example, I'm going to consider the data in the file car_sales.sav. And this file is under the folder samples of the IBM folder of the SPSS folder, which is already installed in your computer. I'm going to then show you practically how we can do factor analysis with the objective of data reduction. So suppose you have opened SPSS. Now you go to Files, Open, Data, or you can also click this one, which is the button Open. Mine, the folder is already open because I opened the file before. But for you, you may be under Documents folder, or you may be under Desktop. Suppose you are under the C folder. I'm going back, as you can see here. If you are under the C folder, then you need to go to either Program Files or Program Files times 86. So either it can be under this, and then you need to check it by pressing I. There is no IBM under this, so my IBM folder is not installed under the Program Files folder. Then you go up, then you open this one. Yes, so IBM is here. You click it, SPSS, you click it, the statistics, you click it, 23, and then you click it. Here you have a folder which is by the name Samples. Then English. Under here, you have a file name which is called car_sales.sav. The .sav means is SPSS. Then you open, and it looks like this one. For this, I'm going to consider the variables from vehicle type until efficiency. So vehicle type, price in thousands, engine size, horsepower, until efficiency. So altogether, I'm going to consider 10 variables. And I want to represent these 10 variables in smaller variables, and then see what percentage is going to be explained by the components that I'm going to use, or the new variables that I'm going to use to represent the 10 variables. So what do I have to do? I have to first go to analyze, and then dimension reduction, and then factor, and then I have to select from the vehicle type variable until the efficiency. Okay, now I moved the 10 variables to the variables box. Then I am going to check if factor analysis is needed. How do I have to check? I have to consider KMO and Bartlett's test. So I have to click on descriptive, and then in here I have to select KMO and Bartlett's test, and then continue. Okay. If you check, this is showing me the KMO value is 0.8, which is greater than 0.6. And the Bartlett's test is significant at 0.05 level of significance. So factor analysis is needed. Okay, let's now go to the next step. Next step, I need to extract the variables. Analyze, dimension reduction, factor, and then go extraction. In here, I need to use the method of extraction. And the default one is principal component analysis, but you can also use other methods, as you can see here. And the components with eigenvalue greater than 1 will be selected. This is a default value. You can also change this. You may also say, I want to be 0.8. But for now, let's just keep it, eigenvalue greater than 1. And if you want to look at the script plot, the script plot is a plot where it shows you or helps you to determine the optimal number of components. And maximum iteration, you keep it as a default. You just click on continue. Okay. In the script plot, as you can see, there is a jump between the third and the fourth component. So this is indicating that these components doesn't contribute to the solution, whereas the first 3 components contribute to the solution. That's what's indicating. Now, this is the initial commonalities, and this is initial eigenvalues. You will have also the same number of eigenvalues as the number of variables. We have 10 number of variables, and eigenvalues are also 10. But in the case of extraction, sums of squares, loadings, then we will have only 3. It means there are only 3 components with eigenvalue greater than 1. That's why we have only 3 here. Look, 1, 2, 3. And they explain nearly 88% of the variability in the original 10 variables. Okay. That's why we have how many components? 1, 2, 3 components. So this is indicating that it is advisable to have 3 components to summarize the 10 variables. And which variables are going to be grouped under component 1, and which variables under component 2, and which variables under component 3, we need to do rotation. So it's like rotation is repositioning. And then by using varimax or other methods of rotation, then we can also estimate the representation of the components. So for rotation, it determines what the components are representing. So we need to go to analyze and dimension reduction, factor, in here, rotation, And then I need to choose Varimax. And the maximum iteration for convergence is 25. I can also say 50 as I wish. Then continue. And then, okay. As you can see here, this was total variable explained. This is a component matrix. And this is the rotated component matrix. The next activity we need to do is we need to name the components. So that's our task. That's the researcher's task. SPSS will not give you. SPSS will give you the values for each component. If you see here, for the first variable of the first component, this is very small and negative. Price in thousands is very large, 0.9. And the other values is small. And also engine size, which is 0.753. And horsepower, which is 0.9. If you look at this, the other values are smaller. So the first component mainly represents for price in thousands. So it is highly correlated with the price in thousands. Okay, what about the second component? To determine the variables which are going to be combined in the second component, we need to check the high value in this column and the low values in other columns. The high value here is will base. And here is low, here is also low. And the other one is width. And the other one is length, which is 0.943. And the value in the other column are small. So the second component is related with length. What about component 3? Let's check. For component 3, the value for vehicle type is very large, and the value in the other column are small. And so vehicle type is component 3. And any variables will be combined, which are related to this. So I'm saying component 1 represents for price, and component 2 is for length. And vehicle type is component 3. Okay. So that's it. Then what's the next activity? We need to save the components for further analysis. How do we do it? We can go to analyze again, dimension reduction, factor, and then scores. In here, we can click on save variables and also then regression and display factor score coefficient matrix. Then continue. Then, so that is the value. As you can see from the beginning, we have the KMO and Bartlett's test. We have the total variance explained. So in our report, this table is very important. This table is also very important. And this table is important. And finally, this table is important. And then we need to name the new variables. Let's check if the new variables are in the spaces. So this new variables factor 1, factor 2, and factor 3 are the new variables.
This suggests that you can focus on price in thousands, length, and vehicle type in further analysis.
Okay, that's how we do data reduction in a species. So for today, this was what we had. And please share, like, and comment. And thank you very much. And see you next time. Bye.